Taking a look here for question number 6, this is a normal distribution problem. The reason I can see that is because it says right here that it follows a normal distribution. So the very first thing I'm going to do is I'm immediately going to draw my normal curve, and it'll look something like this. And the next thing I need to do is make sure that I put my 3 tick marks over here on the right, and then 3 tick marks over here on the left. Taking a look at this, it says that the mean time is 10, so that means I need to put a 10 right here in the middle. And then it says a standard deviation of 0.5, so that means that this is going to be 10.5, then 11, then 11.5. And I can't really turn sideways and write 10.5 right here, so I'm going to leave that blank. This right here is going to be 9.5 and 9. So then this is going to be 8.5 right here. So the question is how do I get 65% out of this? Because right here you can see approximately 65% of these laptops. Well, I know that if I start right here in the middle and color all of this right here, that's going to be exactly 50%. Well, I don't want just 50%, I need more than 50%. As a matter of fact, I need to get all the way to 65. Well, here's what that tells me. If I were to change these to z-scores, remember a z-score of 0 would be right here in the middle. Now, if I go right here to a z-score of 1, this z-score of 1 would give me 50% plus what I'm about to highlight in green right here. Well, from the empirical rule, we know that this green section right here is 34%. Well, 34% plus 50% is way too high for what I need. So I know that I'm going to need a positive z-score, but I don't know exactly what z-score gives me the 65%. So I'm going to come over here to my z-score table. If I start to take a look here, I can see that these are all negative z-scores. Well, I know that my z-score has to be positive, so if I come and look here, I can see for 65%, the best guess that I'm going to have is either 0.4 in the 0, 0 column, or possibly 0.3 in the 0, 9 column, which is this part right here. So taking a look, I'm going to say 0.39 is my best z-score. So hopping back over here, I can say, well, the best z-score guess that I have is going to be 0.39, but now I need to figure out, okay, what numbers is that? Well, taking a look here, I can see clearly I'm not going to stop at just 8.5. I'm going to keep going. So if I went to right here and went even further, I could say that this is effectively the number 8 right here. And yes, technically the orange does keep moving past that, but I'm just going to go ahead and say 8 is my lower boundary. The question is, what is this going to say? So if I go 0.39 and say that's my z-score for a piece of data that I don't know, but I do know that I subtracted 10 because that was my average, and then divided by 0.5, this is now going to turn into a problem where I can say that if I put this over 1, I can simply cross multiply in this direction right here and say that that's going to give me x minus 10 is equal to, and now if I do 0.39 times 0.5, I can say 0.39 times 0.5, and I get 0.195, so 0.195. Solving for x, I can just say add 10 to both sides, and when I solve this out, I get that x is equal to 10.195 hours. Well, what does that mean in terms of time? Well, I can say that that's 10 hours. And then if I take the 0.195 and multiply that times 60 because of 60 minutes, I can say that that is going to be a grand total of about 11 minutes. So roughly 10 hours and 11 minutes. So what are the two numbers? I can now put these together and say 8. So I can say between 8 and we said 10 hours and 11 minutes.